FE200 is celestial navigation on flat Earth. So we're not going to be going over the mainstream globe method where I believe it's spherical, trigonometry, and a GP. We don't need to know that. So what we're going to do is measure right angle triangles from our flat Earth and end up finding the location of the stars. As you know, a sextant can only work on a flat Earth, and because of that, we get an angle of elevation. For example, halfway up would be 45 degrees. And there's a 3-star fix that allows us to know exactly one position on flat Earth where you can see all 3 of those stars. Now, the height of the star, the physical height, does not matter. Neither does a GP. So when you're doing globe conspiracy propaganda pseudoscience, you have to invent a whole bunch of abstractions based around right angles so that they can say they're using a globe. But you'll see what we're doing. It's so simple, and I'm actually one of, I think there's only 2 people who have completed the MC Tune $10,000 sextant challenge. As a senior flat Earth researcher, I was able to find the location, and someone else, Flatsoid, he's another senior flat Earth researcher. So me and him both got right at that same location in the sea. And the method I used is published. You can look through it. Now, what I want to do is actually get you to do it firsthand knowledge and go through the test doing it with the software. So that's why this course costs $20, but our software costs $20. So I'm kind of trying to bundle it in. It's like if you buy the software, you can get this course for free, I guess, if you want it. If you actually, yeah, if you have the software, you can just message me. I'll give you a coupon code for this FE200 course. But for all of the students here, if you buy this course, you'll then just get the academic version for free. You'll just get an email with your way to log into that. So the academic version of the Firmament Tracker's flat Earth model allows you to do this on your computer. And I have a 4K monitor, so my screen's massive and it looks really, really nice. And if you have a good processor or graphics card, what it does is it allows us to do more of these advanced features. So in the academic version, you can do a 3-star fix. You can set the 3 locations you want and then interact through it over flat Earth, see the feedback of it, and we go into a lot more advanced concepts as well. So even without the software, looking up in the sky, how do you find your latitude? Well, we know that Polaris is always going to be equal to our latitude. So let's say I look up and see Polaris at 17 degrees from my horizon. Well, that means my latitude is 17 degrees. And it's true, I'm in Belize. And also in the south, there's a way to do it as well. But you have to learn how to do these methods because there's no such thing as a south star. It's an empty imaginary spot. But when you learn the sky, like all flat Earth navigators have for thousands of years, you can look at those constellations and know exactly what your latitude will be. There's an imaginary spot called the South Celestial Pole that all the stars rotate around, and that will also be equal to your latitude. Hey, little kitty. Come here. So thank you guys for taking an interest in the FE200 course. I look forward to you purchasing it. So as you know, some of the revenue will go towards feeding Ginger, you little kitty, and then also going towards making sure that the platform itself stays up. It's $50 a month that the Flat Earth University now has to pay for this. So thank you for taking an interest in FE200. It's a very unique course because you're going to be using my software that I developed, and we're going to be going over something that globers refuse to acknowledge can only happen on a flat Earth.